Hi everyone! In this video, we're going to be going over the derivatives of trig functions, exponential functions, and logarithmic functions. Now, these are basically just going to be functions that you kind of just have to have their formulas memorized, and I'll go ahead and show you guys those. So these first ones I'm going to go over are the trig derivatives. And an easy thing to remember with these is any of the trig functions that start with a c are going to have negative derivatives. So the cosine, cosecant, and cotangent are all going to be negative derivatives. Okay, and now these are just ones, again, that you have to just kind of have memorized. So if you guys want to pause this video and write these down, go ahead and feel free. And now I'm going to show you guys the derivatives of exponential functions. Again, these are just ones you have to have memorized, but they're pretty easy. The derivative of e to the x is e to the x. The derivative of a to the x, a being any number, that's going to be equal to a to the x times ln a. Now, these are actually the exact same derivative, right? Because for e to the x, our base is e, so that would be e to the x times ln e. ln e is 1, so it's really just e to the x times 1, but we don't ever write that. We only write it as e to the x. So these are actually the same. You don't really need to memorize two different ones for this one unless you want to. All right, and then next we have our logarithmic functions. We have ln x, that is 1 over x, and then we have log base a of x is equal to 1 over x times ln of the base. Again, this one is the same because ln of our base for our natural log function, that's ln of e, which again is 1. So these are the same again. We usually don't write it as 1 over x ln e. We only write it as 1 over x. But again, if you guys want to pause this video and write these down, because these are just ones that you kind of have to have memorized. But they are the same. We just don't ever write ln of e. All right, so now I want to go over some examples using these derivatives. So for this first example, this one's going to be a little bit more in-depth. We want to find the equation of the tangent line to the curve y equals 4 sine x at the point pi over 6 comma 2. Okay, so the things needed to write your tangent line equation is you need to know the slope of the tangent line and you need to know the y-intercept of the tangent line. Now, if you remember, the slope of the tangent line is equal to our derivative at that specific x value. So we need to first find our derivative of our function. So in this case, we have f prime of x is equal to, and we want to find the derivative of 4 sine x. So if you remember, the derivative of sine x is cosine x, and that 4, any coefficient of your derivatives are just going to carry over, so our derivative is going to be 4 cosine x. Okay, and in order to find the slope of the tangent line, we're going to plug in our x value into our derivative function. So we have f prime of pi over 6 equals 4 cosine pi over 6. Okay, so if you guys remember on your unit circle, cosine of pi over 6, that's square root of 3 over 2. So it's going to be equal to 4 times square root of 3 over 2, which is equal to 2 times the square root of 3. Okay, and this is going to be equal to our m of our tangent line equation. Okay, now there's two different ways that you can find your b or find the rest of your equation. So the first way I'm going to show you is by using the slope-intercept form of an equation of a line, and that's you're going to be plugging in your slope, your x value, your y value, and then solving for b. So in this case, we have 2 equals pi over 6 times 3 times 2 times the square root of 3 plus b. Okay, so for this one, we have 2 equals, just to simplify this, 2 square root of 3 times pi over 6, which is going to end up being square root of 3 pi over 3. So then b is equal to 2 minus square root of 3 pi over 3. And this is the exact value for b. If you wanted, you can solve for the decimal for b, and that's generally accepted on most homeworks. So our entire equation now, if we plug in our m and our b, is y equals 2 square root of 3 x plus 2 minus square root of 3 pi over 3. Okay, and only that last part is divided by 3, so let me emphasize that a little bit. Okay, so this would be our equation of our line. And then alternatively, another way that you could have done this is by plugging in your point and plugging in your slope into the point slope form of your equation, and then simplifying that into the correct form of the slope intercept form, because generally tangent lines are written in slope intercept form. Okay, so either way you could do it. Generally you just solve for b and do it that way, but the other way is also fine if you wanted to do it that way. Okay, now let me clear that and let's go on to the next example. This next example, we have f of x is equal to cosine x, and we need to find the second derivative, the third derivative, and the fourth derivative. Okay, just for notation, in case you guys are unfamiliar with this, each apostrophe adds a derivative, right? So if we have 2 apostrophes, that means the second derivative. If we have 3 apostrophes, that means the third derivative. And then generally around the fourth derivative, we just start putting a number instead of having, you know, a bunch of apostrophes, because that can probably get confusing. Okay, so this particular example wants us to find the second, third, and fourth derivatives. Okay, well, we first need to find the first derivative in order to find the second, third, and fourth, right? So for this example, f prime of x, if our function is cosine of x, the derivative of cosine x is negative sine x. And if you didn't know that, then you could look back at the beginning of my video, or if you had it written down from the video as well. So our first derivative is negative sine x. And then now we can find the second derivative. The derivative of positive sine is positive cosine. Therefore, the derivative of negative sine is going to be negative cosine. Okay. Again, that coefficient of a -1 just carries over. Okay, and then now we can find the third derivative. The derivative of positive cosine is negative sine. Therefore, the derivative of negative cosine will be positive sine. Okay, and as you can see, these sines and cosines, they really just make us circle back to the very first function that we had, right? Because by the time we get to the fourth derivative here, the derivative of sine is cosine. Okay, so by the time we've taken 4 derivatives, we are already back at our original function. And this is really important for cosine and sine functions, and you will see this in Calc 2. This is a very useful technique for being able to solve integrals using integration by parts. So just keep that in mind, in the back of your mind for your future class. Alrighty, moving on to the next example. I have just a bunch of random easy ones that we can go over really quick. Ooh. Okay, so we have here we have an exponential function x 6 to the x, and this is going to be the a to the x function formula that I showed you guys. So the formula for that for a to the x d over dx a to the x, that's equal to a to the x times ln a. So in this case, this is going to be equal to 6 to the x times ln 6. Okay, that's pretty easy, right? Now this next one, we have a polynomial as well as an e to the x exponential function. Okay, so this one's going to be equal to, and again, for the terms that do not include an exponential function, you're just going to be using normal power rule to take the derivative. So for this first one, we have 4 times 4, 16, 4 minus 1, 3, and then just 3 for this negative 3x. Now for this next part, we have 7e to the x. You might remember the derivative of e to the x is e to the x, and that coefficient is just going to follow right along there. Okay, so that's the answer for the second one. All right, now this next one, we have another e, but this time we have a function in the exponent, right? We don't just have an x. So for this one, we actually need to use the chain rule. And if you're unfamiliar with the chain rule, please check out my video on the chain rule. So basically, we have our outside function, which is e to the x, and then we have this other function that is embedded in the e to the x, right? Because our other function here, we have negative 7x to the 10th plus 7x to the 6th. That is taking place of our x. Normally, that is in our exponent, right? So for this one, we want to do on the chain rule, the derivative of the outside e to the x is just going to be 2e, and you keep the inside function the same. Oop, why is this not? Okay, and then we multiply that by the derivative of our inside function, or in this case, the derivative of our exponent, which is going to be negative 70x to the 9th plus 42x to the 5th. Okay, pretty easy, and if you want, you can even put this in parentheses, just to make sure that that e gets distributed to both terms. Okay, so that's the answer to the third one. Lastly, we have a logarithmic function. Now, if you might remember that the derivative of ln x is 1 over x. So with logs, we have this additional ln of our base, right? And in this case, we have a 3 here as our coefficient, and our 3 is just going to carry right along with that. So I'll write it as 3 multiplied by 1 over, we have ln of our base. Our base here is 4. What is that? There we go. Multiplied by x, because x is what the log of x, so that's what it's going to be multiplied by. And then we have this plus 17, but that plus 17, that's the derivative of a constant is 0, so that's just going to be plus 0. And we can always rewrite this as 3 over ln 4 x. There we go. Or x ln 4, it doesn't really matter. But that is the answer for that one. So with these, you just want to make sure you take them step by step and make sure that you know that you have your formulas memorized, and also you're taking into account if you need to use the chain rule. Okay, now lastly, I have one more example here for you guys. So our function is equal to 2 ln x. We want to find the derivative. We want to find the derivative with plugging in 9, the second derivative, and the second derivative with respect to 9. Okay, so first let's find our first derivative here. So if you remember, the derivative of ln x is 1 over x, and we have just that 2 that's being multiplied by that, right? So 2 times 1 over x, that's equal to 2 over x. Okay, and we can also rewrite this as 2x to the negative 1, right? So remember, you can bring anything in the denominator up into the numerator by making that exponent negative, okay? And this is going to be helpful for whenever we take the second derivative, okay? So we want to find f prime of 9. We're going to be plugging in 9 into our derivative. So that's going to be 2 over 9, or 2 times 9 to the negative 1, okay? Now, lastly, we want to find the second derivative. Okay, and we want to look back at here at our 2x to the negative 1, because that's going to be more helpful for whenever you're taking the derivative, because we need to use the power rule, right? So this is going to be equal to 2 times negative 1x to the negative 2, because negative 1 minus 1 is negative 2. Okay, and we can rewrite this as negative 2 over x squared, right? Because that negative 2 power means that it's in the denominator, all right? So then lastly, we want to plug in our 9. So that's going to be negative 2 over 9 squared, which is negative 2 over 81. Okay, so pretty simple, just take it step by step, and if you have a problem like this, write out every step and write out what you're plugging in, and it'll really help you to get the correct answer. Right, I think that is my last example. Yep. All right, so I hope this video was helpful, guys. If you have any other questions about calculus, feel free to check out my other videos, or feel free to sign up for tutoring. Our link is on the New River website, nr.edu, under current students and academic assistance, or academic success center, and you can fill out our form on there. Bye, guys.